Okay, let's try again. Uh, you've been following this series of videos. I know I said previously the last was going to be the last video. I lied. This is going to be the last video of this series. In this video, we are going to show how to distribute some workload using the previously functions that we have been deploying through this tutorial. You've been following through. Previously, we deployed this Hello World application using AWS Serverless Application Modeler. And then we later changed this initially Hello World application to this Data Faker application in which we were creating a JSON. And then additionally, we created a Glue job in which we were taking that JSON that we were creating and saving it as a parquet using this function that is here to parquet from this library AWS S3 to parquet function. For that, we said that you need to set up this trigger. So for each file that is created in the folder, the glue job is going to be invoked with the path and the name file. Since the name of the file that we are generating is being generated randomly, in order to invoke the glue file, we need to pass the name of the file with this S3 Lambda trigger function. And now what we are going to focus on is how can I invoke that function, the first Lambda function, to create a JSON recurrently so we can, distribute the creation of files, the reading of files, or the writing of files in a non-structured format. Could be a JSON, a CSV, a TXT. How can I distribute the task of reading multiple files or writing multiple files, from to S3, from structured format to a structured format? How can I make that very efficiently, distributing set transformation, set creation, set reading, set writing? How can I do that? This is the object of this video, or the purpose of this video. In order to answer that question, we are going to use this map function that we have here. What we are doing is invoking the previous function that we have created here, which is if I go to my AWS console and then I go to functions and then I sort by, well, in my case, since I have several functions deployed from some other stacks, if I sort by last modified, I can see I have this hello world function application and it ends in T, A3, I7, etc. Oops. So what I'm going to do, like in the previous video, I'm going to go to my working directory and I'm going to create a folder within this directory called data faker. I'm going to create this function called mappa underscore mapped underscore data faker. And then within this folder, I'm going to create this file called app.py. Within this file, I'm going to copy this code that I have here and I'm going to paste it. With the only difference that this function name that I have here, I'm going to change it for this function name of the previous function that I deployed in the previous video, which is our hello world function, which is the function we are using to create one JSON. And what we are going to do is to invoke this function recurrently. I'm going to hit here and then configuration, sorry, monitoring. And then let's filter the last 3 minutes. So we have no invocations in the last 3 minutes. Uh, what I'm going to do here is I'm going to say updated here. And what I'm going to do here now is hit SAM build and then SAM deploy. And you will see that this resource that I have created here, I have created previously already to record in this video. Uh, so anyway, any at the moment you are creating this folder, at the moment you are copying this code and creating this file and copying and pasting and changing, updating the function name for whatever function name you have actually deployed under your own stack. Whenever you deploy those changes, you are going to get this message on the AWS SAM console. It's going to tell you either if it is creating the resource or updating the resource, if it has been created previously. Um, whatever the status of your application is, at the end you should have this message: successfully created, updated stack. And like the resources that have been either created for you or updated for you. Then we are going to try to, I'm going to open another tab. And I'm going to, again, check my Lambda function, sort by last modified. I should see the functions that I just have deployed 54 seconds ago. This is my map data function with the change. It says objects added, updated. Then if I check the source code, I say objects added, updated. Now I have previously created this. Let's try testing this function. Let's create a new. Um, okay, so let's have a look to this test event that I have previously created. I would like to create a new. Oh, create new. Okay, forget that. Click on create new test event, and then we are going to create a new event. Event 2. Case. Then I'm going to write the keyword and rows because this function is a bit different than the others that we have previously deployed, in the sense that here we are using event and we are using the keyword and rows to try to invoke this function. So let's say I have another dictionary with another keyword that is not in rows. If I click save here and then I invoke, I will get an error. There's key error and rows. Why? Because we are expected the end rows keyword to be on whatever dictionary you are passing onto the function. So let's correct that. Let's pass this keyword end rows and then give it a value of 5 and then save. Event already exists, I know. So let's try go here and then edit event and then 5 and rows, save, and then invoke. And what I should see is this successful invocation message that says 5 objects have been updated. If I go here to monitoring, and if I update this, I should see now some invocations. And because I don't know if you notice, I click some previous times on test, we can see here that there are several executions, not only the 5 executions that I did, but 50 because that was the original value when I clicked tests. If you notice that this is what's happening here. And then if I click here in update, um, let's say here with those invocations, what this function is doing is creating some objects into this S3 folder that I have here. So it is randomly creating some folders here. So I have 35 objects so far. Might not be the correct folder. Fake database. This is the correct folder. See, just check that we are in the correct folder. Should be called fake database. Fake database. Okay. Let's test again. We have 115 folders created so far. Let's try invoking this map function. But now we are going to invoke it 50 times again, then save, then invoke. And we should see that 50 folders are being created here. Hundred and 15 plus 50. Are we missing some folders? Perhaps. Anyway. And then at the moment these folders are being created here, these jobs are being queued, are being aligned. Why? Because for each of the files, here you can see in this parameter, we go to the glue job that we have deployed here. You can see that one job is being run for each file that we are creating, for each JSON that we are creating. We are immediately reading that JSON, converting it to a parquet, and storing it into this glue catalog that we have here. So this is my fake database. Previously, my number of rows were 4. If I execute again, well, let us execute a count. We have 125 results, 125 rows. Let us run this database. Let us eliminate this table. Delete. And then let us delete this folder. And then let's run our pipeline from the beginning again. Let's see if these JSONs have already finished, otherwise. Okay. This is almost finished. And you can see here that the reason why these are waiting is because here in job details, we have our concurrency set up to only 10. Maximum 10 jobs are going to run at the same time. Let's change that. Let's put up 100 to speed that up a little bit. And also notice here that in my job configurations, I have 1/16 of data processing units. That's very important whenever you are trying to spread computation using this technique. You need to have the smallest job you can here. And the smallest job available in Glue configuration is Python shell with 1/16 of data processing unit. So take that into account, save, and then I'm going to hit again with all of the objects deleted and the table deleted. Let us try insert 101 rows, save, invoke, seems to be running okay. What's going on here? Monitoring. The last 5 minutes, apply. We can see this async events 50. You can see there are 101 invocations. But then if I go here, runs, I can see all of these waiting. If I go here, I can see, I already can see 100 objects created. If I go here, I update this. I see that this table has been created again. The one that we just deleted. I go execute the count. 135. Okay. Okay, let us work on that. Deleted table, recreating table, um, running in parallel. But hopefully the idea was clear enough. The idea was to exemplify how to execute um, several times or several threads, several instances of this job, meaning how to how to distribute computation over a set of files using Python, using AWS, using Glue, using Lambda functions, um, with your local development setting, using AWS Serverless Application Modeler in order to develop your whole application, to keep your whole resources, together, making sense, to deploy changes, to update parameters, to update permissions and roles and whatnot. That has been the purpose of this series of tutorials. Here, the last example I am executing, you can see I am executing in parallel 100 threads. for a job of 500 dress total. Um, and at the end, what we are doing is just to process files, to read a file, write a file, then read it again, then write it as a parquet, insert it into a Glue catalog, which is with what we have here at the end. If I execute this count again, we should see this number is already been updated. So thank you for your attention. Good afternoon. See you on the next one.